Assalamu alaikum everyone. Minus 540 is the correct answer. Good job. Yeah, I did a stream on binomial, quite an extensive stream, and I am expecting binomial to come in paper 2, so you can check that out. And I'm talking about paper 2 variant 2. Walaikum salam, walaikum salam. Acha, so before I start, you guys can download the worksheet from the link in description. In fact, let me check अगर मैंने link डाला है description में. I think डाला है. I'm good. How are you? So how's the preparation for the exam? Yeah, Rafe, I'm extremely tired, but yesterday when I did a poll, everyone voted for velocity vectors, so here I am. Streaming velocity vectors. Acha, let me tell you guys. Let me tell you guys one thing, because I'm still getting questions from you guys about whether this is part of the syllabus or not. So let me give you a contrast and tell you what's part of the syllabus and what's not part of the syllabus. So basically, questions like these, where you're asked to you're given the speed and you're given the bearing, and you're asked to break it down in vector form. Questions like these are still part of the syllabus. Okay. Now let me show you the questions that aren't part of the syllabus anymore. Okay. Because I don't know why you guys still have that confusion. I think what the primary source of confusion is the fact that you guys might be using the old book, the old Addmath book. Acha, so let me take like an old past paper to give you guys an idea as to what is not in the syllabus anymore. So from 2019, in fact before 2020, yeah, you will come across questions which will have something like speed in still air, yeah, stuff like this. So take a good look at this question. Every time you have something like the plane can fly at a certain speed in still air, or the boat has a certain speed in still water, these are the type of questions that are no more in the syllabus. ठीक है, so जब आप practice कर रहे हो, skip these questions. They're no more in the syllabus. They were removed from 2020. So 2020 and onwards, you'll notice that these questions are no more in the syllabus. However, yep, we don't have this. However, what's still in the syllabus are questions like these. These are still pretty much in the syllabus. Sir, could you please solve the question from May June 2011? Is that a vectors question? Is that a velocity vectors question? Resultant speed also is not in the syllabus. Okay, because see, questions where you have like a plane traveling in still air and a boat moving in still water, those are the type of questions that are no more in the syllabus. But when you have like an object of which you know the position vector and you know the speed and the direction in which it's moving, and it's not traveling in still air or in still water, those are the type of questions that are still pretty much in the syllabus. Okay, so anything that has speed in it and has something or the other to do with vectors, that is still in the syllabus. All right. Yeah, those questions are not related to. Okay, I'm not sure exactly what you're talking about. All right. Anyway, so let's start and then you guys will have an idea as to what are the type of questions that are still in the syllabus. Okay, so I shared a video on my Instagram which was basically the conceptual video, so I hope you guys have seen that. And the reason why I'm saying that is because in today's video I'm only going to be solving past paper questions. Sir, can you do question 10 from the file you have shared? Yeah, sure, I can do that. So what about resultant speed? Farheen, I think I've already answered that. Resultant speed is not in the syllabus. See, anything that has to do with speed and has vectors in it, that's still in the syllabus. Question 10. Okay, इसकी बात नहीं Okay, इसकी बात करें आप लोग. Yeah, this is in the syllabus. अच्छा, do we have any moderators? Can you guys please कोई भी spam करे ना तो message नहीं delete करना, just hide them on the channel. Alright? Hide them on the channel and or put them in timeout, one of the other. ठीक है? No need to delete, that will take forever. Just hide them and yeah. What about adding vectors? Of course, that's in the syllabus. What kind of a question is that? Of course, adding vectors is in the syllabus. Anyway, so let's start. And before I start, as always, those of you who are watching, if you guys could just like the stream, that would mean a lot. And also an announcement, and that is at 5 p.m., inshallah, give or take, Pakistan time, I will be streaming some past papers, okay, from recent years. Most likely February, March papers on Twitch. So I shared a post on YouTube, so you guys can join that at 5 p.m. Okay? I'll share the link over here as well. So 5 p.m. Twitch pe inshallah I'll be streaming yearly past papers. Taro, let me just share the link here. Here it is. Let me pin it as well. Okay, now. Forget about where the post is. मैंने अभी link लगा दिया है. ठीक है? You guys can use this link to join. Okay, so like I said, let's get to work and see what's what. So let me start off with an easier question. Okay. And then we'll gradually increase the difficulty level. Okay. Okay, let me think of an easier question. Okay, so here it is. Question number 5 of this worksheet is relatively easy. Okay, ye karte hain. And questions like these are also very common. So here we have a particle P moving with a velocity of 20 meters per second in the same direction as 3, 4. Find the velocity vector of P. So how do you find out the velocity vector of P? Remember, there's only one way to find out the velocity vector when you're given the speed and the direction. Okay, so this question is very similar to the other questions that we did in vectors, where you're given the magnitude and you're given the direction. So what you do is think of 20 as your magnitude and 3, 4 is the direction vector. So in order to find out the velocity vector when you're given the speed and the direction, here's what you do. The velocity vector is equal to speed multiplied by the unit vector of direction vector. Okay, this is the standard way of solving questions like these. So here's what we're going to do. So I'll start from the easier questions. Okay, I'll try and solve all the questions that we have over here, but I will start from the easier questions. Okay, yeah. So what's the speed? The speed is 20. And how will I find out the unit vector of direction vector? Here's what I'm going to do. 3i plus 4j. And if you want, you can find out the magnitude over here. It's going to be square root of 3 squared plus 4 squared, which is going to be square root of 25, which is going to be equal to 5. So divided by 5. So 5 ones are, 5 fours are. Multiply this, what do you get? 4 into 3 is 12. So 12i plus 4 into 4, which is equal to 16j. Now you can write it like this, or you can write it like this. 12, 16. And there you go. That's your answer to the first part. Okay? Fairly easy, nothing too complicated. And yeah. Next question. Next question is, at time t equals to 0, a particle P has position vector 1, 2 relative to a fixed point O. Write down the position vector of P after t seconds. Okay, so a position vector of P after t seconds means that we need to find out, we need to basically form an equation, you can say, an expression in fact you can say, which will help us locate where this object is, where particle P is at any value of t. So for that, we always take the position vector, which is 1, 2, plus the velocity vector, which is equal to what? Which is equal to 12 and 16. So 12, 16, you can think of it this way, that every second this particle moves 12 units to the right and 16 units up. Why right and up? Because they're both positive. So what will happen in t seconds? For that, all you need to do is multiply it by t. So now you have the position vector of p after t seconds. Okay. So the position vector of p after t seconds is going to be 1, 2 plus 12, 16 into t. So that means if you want to find out where this particle is at after 5 seconds, so all you got to do is plug in 5st. If you want to find out where this particle is in, let's say, 10 seconds, so all you got to do is replace t by 10, simplify, and you'll get your answer. Okay. Now, this is a question. Questions like these are also not very common, but this is a concept in velocity vectors. Okay, and this is the collision concept. All right. So here's what we're going to do. It says a particle q has position vector 17, 18 relative to O at time t equals to 0 and has a velocity vector 8, 12. So the first thing you want to do is you want to find out the position vector of q after t seconds. So let's do that. The position vector of q, after t seconds, or you can say at t seconds. This is where it's going to be 17, 18 plus 8, 12, and this gets multiplied by t. Okay, so this is where q is going to be after t seconds. Okay, so I'll write t over here to show that this is the position vector of q after t seconds. Okay, Acha. Then it says given that p and q collide. Now every time the question says that the particles are colliding, what you do is you equate their velocity vectors. Okay, remember we equate the velocity vectors. All right, so here's what we're going to do. We have 17, 18 plus 8, 12 into t. Okay, so we're going to equate this with the position vector of p after t seconds. So that means this is going to be equal to what? This is going to be equal to 1, 2 plus 12, 16 into t. Okay, अब कोई भी एक इक्वेशन लेके हम सॉल्व कर लें, हमारा आंसर आ जाएगा. What do I mean by that? This is what I mean. 17 plus 8t, okay, 18 plus 12t. If you open it up, and this is going to be equal to what? This is going to be equal to 1 plus 12t and 2 plus 16t. All right. Now we need to find out what? We need to find out the value of t when they collide. So that means here's what I can do. I can take the x component from q and I can equate that with the x component of p. It's like, you know, when we have to prove that two vectors are parallel, except that here we're not dividing, we're equating them. So 17 plus 8t is equals to 1 plus 12t. Let's see what happens. 16 is equals to 4t. Let's write this nicely. 4t is equals to 16, which means t is equals to 4 seconds. And there you go. That's it. That's your answer. Sir, isn't it position vectors, not velocity? Okay. Yeah, you're right. Equate the position vector. You're right. Yeah, you equate the position vectors. Okay, now if the question asks you to prove that they are colliding, then in that case what you need to do is, quickly I'll reiterate that you need to equate the position vectors, sorry, not the velocity vectors. ठीक है, इसके notes मैंने share किए हुए हैं, उधर से जाके download कर लें. ठीक है, you'll understand what collision is and what velocity vector is. Okay, I've done multiple cases of finding out the velocity vectors. Just download it from download the notes from the description. You'll find them over there. Okay. Achha. So when the question says prove that they're colliding, or sometimes the question will ask you to prove that they're not colliding, or sometimes the question will just ask you whether they're colliding or not. In that case, what you do is, so like for example over here, if let's say the question was prove that they are colliding. So in that case, I would have also equated the y components and I would have shown that we get the same value of t for both the equations. Okay, that's what I would have done. So let's do that over here. Again, it's the exact same thing happens. You get 16 equals to 4t and you get t is equals to 4 seconds over here as well. Okay, so this shows that they are colliding because we're getting the same value of t for both the equations. Okay. And if the question had said कि show that they do not collide, तो फिर हमारे पास we would have ended up with two different values of t. Okay. So is it necessary to show the equality for both x and y components? No, it's not necessary. If the question is asking you to just find out the value of t where they're colliding, then just use one equation and find the value of t. But if you want to play it safe and for your own satisfaction, if you want to make sure that you've gotten the correct value of t, then to further check your answer, you can use the other equation and make sure that you're getting the same values. Okay. Now, here the question doesn't end because not only did we have to find out the value of t, we also had to find out the position vector of the point of collision. Now, in order to find out the position vector of the point of collision, here's what we're going to do. To find out the position vector of point of collision, plug in t in any position vector. Okay, so just remember this. So let's say कि मैं q का position vector use करता हूँ. So 17 plus 8 replace t by 4, and then 18 plus 12 replace t by 4, and this is what you end up with. So 32 plus 17, 32 plus 17, that gives us 49. All right, and then 12 into 4, 48 plus 18, that gives us 66. And I think somebody here already gave the answer to this, so that is correct. Good job. Sir, synthetic division allowed? Yes, synthetic division is allowed. It's just that you won't see it too often in past papers, but it is allowed. Thank you, Lalina. How do you approach any vector question? Well, first thing you do is you read the question and then decide what it is that the question is asking you, and you find that accordingly. Okay? You're going to have to be more specific with your question. What's your name? Aryan? Yeah, that's even better. Bismillah padke. Okay. So this is an insanely difficult question. So let's save this for, not for the very last, but let's not worry about this. Okay, I will solve this question, don't worry. I will for sure solve this question, but let's do some easier questions first. Okay, let's do one of those questions where you're given the direction and you need to find out the velocity vector. Let's do one of those questions first. Nah, too easy. I mean, not too easy, but not exactly what I'm looking for. वो एक सवाल था ना जिसमें बेरिंग थी. Okay, let's do this question. Okay, how long is today's stream? I don't know, maybe hour and a half or 2 hours tops. Okay. So let's solve this question. Let's see what this question says. This question says, in this question, 1, 0 is a unit vector due east, so that means it's going towards the right, and 0, 1 is a unit vector due north, so that means it's going up. At 1200, a coast guard at point O observes a ship with position vector 1612 kilometers relative to O. So that means this ship was not starting from the origin. In fact, it was starting from a point already 16 and 12 units away from the origin. Okay, the ship is moving at a steady speed of 10 kilometers per hour on a bearing of 330 degrees. Okay, this is an interesting question, because now what you have to do is, now you need to find out the velocity vector using the speed and the bearing. Okay, so think of it this way, that the speed we will use for magnitude, okay, and this bearing will be used for direction. Okay, so notice that you're not given a lot of space, but it's enough given that you use this space efficiently. So first of all, with the help of 330 degrees, let's try and identify as to what quadrant, first, second, third, fourth, is this ship going to be in. Okay, now remember, bearing is something that's measured in a clockwise direction and it's measured from the north. Okay, don't confuse this with theta or anything else. This is bearing, so it's supposed to be measured from the north and it's supposed to be measured in a clockwise direction. Okay, keep all of those things in mind. Okay, so here we are. This is 0, here's 90, here's 180, 270, 360. Okay, so 330 means that it's going to be somewhere in between, or maybe not in between. It's going to be, yeah, in fact, it will be in between. No, not in between actually. Anyway, irrespective of wherever it's going to be somewhere over here. Okay, so this angle here represents 330 degrees. 330 degrees. Okay, so what we need to do now is, I'm just going to erase this north to make some room here. Okay, so what we're going to do now is, we are now going to break this down into x and y components. Okay, so what are we going to do? We're going to break this down into x and y components. ठीक है? अब देखो एक और चीज़, what I'm trying to explain over here is exactly what exactly is this, that, or rather how exactly did the question end up with this. Okay, now we're not supposed to do this over here, but I'm just trying to explain this कि ये exactly question के पास आया कैसे. ठीक है, वैसे तो p की value निकालनी हो तो it's fairly easy, but what I'm trying to explain over here is that how you can use speed and bearing to find out the velocity vector. ठीक है, वैसे तो p की वैल्यू जो निकालनी है वो कैसे निकालेंगे मैं आप लोगों को बता देता हूँ. ठीक है, p की वैल्यू निकालने के लिए remember this, that the magnitude of velocity vector represents speed. Okay, so that means square root of minus 5 squared plus p squared is going to be equal to 10. All right, so let's figure this out. So here we have 25 plus p square, which is equal to what? Which is equal to 100. P square is equals to 75, and p equals to what? P equals to square root of 75, which is equal to what? Which is equal to 5 under root 3. But the question is, is it going to be positive or is it going to be negative? Because theoretically, so we're supposed to have both signs. We're supposed to have plus and minus. So here I have a question for you guys, and that is it going to be positive or is it going to be negative? So for finding theta of vectors, if they said negative x-axis, positive y-axis, which quadrant should we consider? Okay, you're gonna have to elaborate or maybe share a question that you're talking about. Okay, so first of all, p is not representing speed, p is representing the y component of the velocity vector. Okay, and second of all, that can be negative. All right, so that's not the correct explanation because it's speed, so it can't be negative. Nope, that's incorrect. This has to be positive. Why? Because the object is moving in such a way that it's moving leftwards and upwards. So because it's moving leftwards and upwards, that's why you can see that the x component is negative and the y component is going to be positive. So p is in fact going to be positive 5 under root 3. Okay. Now, let me explain to you guys something else over here. Okay, although it's not asked in the question, and that is, what if you're given the speed and the bearing and you're supposed to find out the velocity vector? Okay, so let me do that separately so that you guys don't get confused. Now, as far as the answer to the first part is concerned, that we already have. Okay, it's going to be positive 5 under root 3. Okay, please make a correction that speed cannot be negative is not the explanation as to why it can't be negative. The correct explanation is the fact that p, since the object is moving leftwards and upwards, since it's in the second quadrant, x is going to be negative, y is going to be positive. Okay, that's what the correct explanation is. Okay, now let's say this is the information that you're given, and you're asked to find out the velocity vector. So this is a separate example. Okay, you're given the speed and the bearing and you're asked to find out the velocity vector yourself. Here, part of the velocity vector was given to you, but let's say you're asked to find out the entire velocity vector from scratch. Okay, so in this case, you're going to do exactly what I was doing earlier. First of all, identify the quadrant. So the quadrant is going to be the second quadrant, all right? And this is where the object is headed. So this angle here is 330 degrees. Okay, 330 degrees. So that means this is going to be what? This is going to be 30 degrees. Okay. Now what you need to do is you need to break it down into x and y components. Okay. So here's what I'm going to do. This is the x component, what you're looking at in red, and what you're looking at in green is the y component. Okay. So here's x and here is y. As a safety precaution, here's what I would recommend. As a safety precaution, what you should do is you should break it down like this. You should write minus x already because it's moving towards the left, and you should write positive y so that you don't end up forgetting writing the minus sign with x. Okay? Okay, now, so first thing we need to do is we need to determine what this angle is going to be. So this angle right here, you can find out very easily by simply subtracting 90 and 30. So that's 60 degrees. Okay, I don't expect you guys to not know these concepts very well. These are the concepts of bearing, very frequently tested in math. So I'm not going to go over as to how we got this 60 degrees. Okay. Okay, now let's find out the value of x. So x, as you can see, is the adjacent side. All right, and we have the hypotenuse as 10. So what are we going to use? We're going to use cos. So cos 60 equals to adjacent, which is x, over hypotenuse, which is 10. So what's x equal to? Cross multiply, so you'll have x to be equal to 5. Okay, let me change this color to red so that you guys know what I'm doing. Now let's talk about y. So y, as you can see, is the opposite side, and we have the hypotenuse side, so we're going to use sine. So sine 60 is equals to opposite, which is y, over hypotenuse, which is 10. So what is y equal to? Y is equals to sine 60 multiplied by 10. Make sure that your calculator is in degree mode for this and not in radian mode. So you get 5 under root 3. So that means now the velocity vector is complete. The velocity vector is minus 5 and positive 5 under root 3. Now, let me make one thing very clear. This is not what you were supposed to do in this question. This is a separate concept, and that is what to do or how to find out the velocity vector if you're given the speed and the direction through bearing. Okay, so I hope it's clear. Okay, so I don't think I missed anything. Okay, great. Now let's come back to this question. So this question here says, write down in terms of t the position vector of the ship relative to O after 1200. Okay, so that means time was being recorded after 12 o'clock. Okay, so here's what we're going to do. We're going to look at where the ship was at 12 o'clock. So the question says it was at 1612. In it, we're going to add the velocity vector, which we now know is minus 5 and 5 under root 3. And this we're going to multiply by t. So there you go. That is your answer. I get confused when to use radian and when to use degree measure. Okay, there's nothing to be confused about that. See, if the angle given is in degrees, then of course you're going to use it in degrees. Okay, and if the angle is given in radian, then of course you're going to use radian. Okay, now there are a couple of rules. Whenever we're solving questions that involve trigonometry and the question is of kinematics, we always use radian. And again, whenever we're solving a question of circular measure, then also it's understood that we're going to use radian, because the formulas that we are using are of those scenario when the angle is in radian. Okay. All right. Then it says find the time t when the ship is due north of O. Okay. So what's going to happen when the ship is due north of O? Imagine this. Imagine that you have a ship over here. Okay. And let's say it starts moving from this point. Here's O and here's the north of O. So what will happen if the ship eventually reaches a point which is due north of O? What will happen? Dekho, if your angle is in terms of pi, then it's radians. Alright, if the angle is in terms of pi, then it is radians. Yep, y component will be 0. Good job. Okay. Yeah, x component. X component will be 0. Not the y component. X component will be 0. Okay. So because the ship is due north of O, that means its vector, its final vector or position vector, you can say, is going to look something like this. Okay. The x component is going to be equal to 0, and there will be some y component. So that means 16 minus 5t and 12 plus 5 under root 3 times t is going to be equal to what? Is going to be equal to 0 and y. Now, we're not really concerned as to where it is, as to what the y component is. Okay, we're not really concerned about that. Our concern is to find out the time when the ship is due north of O. Okay, so here's what we're going to do. We're going to do 16 minus 5t equals to 0, which means 5t equals to 16, which means t is equals to 16 divided by 5, so that's equal to 3.2 hours. Now, let me tell you something. If you write 3.2 hours now, you're not going to get full marks. You will probably lose 1 mark. And why is that? Why is it that you will lose 1 mark if you write 3.2, even though there's nothing wrong so far? So when integration has limits of pi, should we use radian to calculate it? Yes, definitely. देखो pi की terms में सिर्फ radian के angle calculate किए जाते हैं, ठीक है? Yes, we have to add the time. So this is incorrect because what we are given, what we need to find out is the time on the clock. Okay, this is the duration. So 3.2 hours, again, you can use the magic key in your calculator to find out the hours in minutes. So 3.2 hours basically mean 3 hours and 12 minutes. Now remember, this is after 12 o'clock. Okay, so 3 hours and 12 minutes after 12 o'clock basically means 15:12. Okay, so when the ship was due north of O, the time was 15:12. Okay. Okay, then the question says find the distance of the ship from O at this point. Okay. So what do we need to do? We need to find out the distance of the ship from O at this point. So we know exactly the value of t when the ship was due north of O. So we're going to substitute that. Now we don't need to substitute that in 16 minus 5t because we know that's going to be equal to 0. But where we do need to substitute it is in the y component. Okay, so that's what we're going to do. So in the y component, it's going to be 12 plus 5 under root 3 multiplied by 3.2. Okay, so let's work this out, see what do we get. And at the same time, okay, you know what? At the same time, since you need to find out the distance, whatever this, okay, so explain this to me. Whatever this component is, that's going to be your final answer as well. Okay, so let's work this out. 12 plus 5 under root 3 into 3.2. ऐसा क्यों है कि whatever the y component is, that's also the answer to the question. Why is that? So here's what I'm looking at, okay? I'm looking at 0 and 12 plus 16 under root 3. Okay. Now the thing is, if I calculate the magnitude, here's what I'm going to do. I'm going to do 0 squared plus 12 plus 16 under root 3, the whole thing square inside the square root. Now 0 squared is meaningless, so might as well just ignore it altogether. The square root and the square will just cancel out each other, so that means the distance is 12 plus 16 under root 3, which is approximately equal to what? 39.712. So 39.7 kilometers is good enough. There we go. Yep, because it's y squared, and when you take the square root of it, it becomes 0. Good job. So why not take the magnitude, because isn't this displacement? Yeah, so we are taking the magnitude. We're taking the magnitude of the displacement vector. Or you can say the position vector. Okay. Position vector technically is the same thing as displacement vector. Position vector tells you where the object is from the starting point, and displacement also is just that. Displacement is the distance, the straight line distance from the starting point. Okay. Why are we substituting hours and not in minutes? Because there's nothing in this question that tells us that we have to convert or anything like that. All right. Yeah, so distance is magnitude of displacement. Okay, so you guys want to do a question yourself? चलिए ये क्वेश्चन करें. Can we leave it in third form? Yeah, you can. The question didn't have a specific requirement, so you can totally leave it in third form. Okay? Only when the question has a specific requirement do you write it in that form. Okay? The one right after. You mean this question? Okay. Chalo, we'll do that question as well. So, but first let's do this question. I want you guys to do this question. The sooner you guys do this question, the sooner we'll be able to do the next question. जी आप खुद करें, मैं कुछ नहीं कर रहा. पिछला पार्ट समझा दें. कौन सा पार्ट रोहेल? Can you narrow it down, please? So can you do a question with two bearings on it? Yeah, I think I know what question you're talking about. We'll do that as well. So does this worksheet all? It contains most of the velocity vector questions, Rafe. Not all maybe, but for the most part, yes. P is equals to 2. Are you sure about that? Are you sure about that? P is equals to 2? P equals to 4. Yeah, P equals to 4. Alright, do the next part. If you guys can do the next part, then you're pretty smart. $108 is the correct answer. Good job. 108 is in fact the correct answer. ठीक है, good job. तो जब आप लोगों को आता है तो आप आए क्यों हैं यहाँ पे? Sir, will you upload the video of the streaming? Yeah, all streams are uploaded. Don't worry about that. In part 1, we have to use magnitude. Yeah, you do. Okay, so remember, what is it of the speed that gives you the what is it of the velocity vector that gives you the speed? It's the magnitude, okay? So that's what I'm going to do over here. A, is a particle which has a velocity vector of, it's right here, pi and minus 3j. So p and minus 3. Okay. Now, since we're given the speed, like I said, it's the magnitude of the velocity vector that's equal to speed. So p square plus minus 3 squared equals to 5 squared. So p square plus, no, actually not equal to 5 squared. Square, so we will square both sides. That's when it's equal to 5 square. So anyway, p square plus 9 equals to 25. When you square both sides, p square is going to be equal to 16, which means p is equals to plus and minus 4. Now, since the question is categorically asking for the positive constant, so p equals to 4 is the final answer. Okay. Okay, I appreciate that. Sir, should we mention that it's southeast? No, if you're given the bearing, that's good enough. Okay, no need to. If you say southeast, you know what that means? That means it's right in between south and east, which means that it's at a bearing of 135 degrees. So if you say that, it's actually wrong. Okay, Josefa, I hope that answers your question. It says read the entire question. It says find the direction of motion of B as a bearing. So you need to find out the direction as a bearing. Okay, and you need to give it correct to the nearest degree. All right. So we're talking about B now. So let's see what the velocity vector of B is. So the velocity vector of B is 3 and minus 1. Okay. So here it is, the velocity vector of B, 3 and minus 1. Now, through the velocity vector, you can find out the direction in which it's moving. Okay. So this is pretty much like this concept over here, except we're doing it in the opposite direction. Previously, it was through the bearing that we were finding out the velocity vector through the bearing. Here, it's through the velocity vector that we're finding out the bearing. So it's kind of the same thing, except that we're doing it in some other direction. Yeah, okay. So 3 and minus 1 basically means that it's moving 3 units to the right and 1 unit down. Okay, so you can make a triangle over here. 3 units to the right, like I said, positive 3 means 3 units to the right, and 1 unit down basically means somewhere over here. Now, what you need to find out is actually, no, wait a minute, गलत बना दिया, ये line इधर आएगी, yeah. So this is 3 and this is 1, okay. Now, what you need to find out is this angle, but you can't find out this angle immediately. So first you need to find out what this angle is, and in theta, you need to add 90 degrees in order to find out the bearing. Okay. So theta can be found by using tan. So tan theta is equals to opposite upon adjacent. So theta equals to tan inverse of 1 upon 3. So that means it's equal to 18.4 degrees. And now the final answer is going to be 90 plus theta, which means 90 plus 18.4, which is equal to 108. No, wait. Yeah, 108.4. Okay. But since you're supposed to give your answer correct to the nearest degree, again, please make sure that you read the question carefully. Your final answer is going to be 108 degrees. So there you go, fellas. That's your answer. Can we leave the answer in column form? What do you mean column form? Here we're supposed to give the bearing, so you can't leave your answer in column form over here. Okay, did I miss anything? No, I don't think I missed anything. It will be minus 1, but the thing is, since we're calculating the angle, we'll ignore the minus sign. Due to this minus 1, we've taken it downwards. If it was positive 1, we would have taken it upwards. Okay. Sir, how do we know fourth quadrant? Okay, so 3 means 3 units to the right, and minus 1 means 1 unit to the down. So 1 unit downwards, 3 right, and 1 down. Okay. Then it says state the position vector of A after t seconds. Okay. So A, we now know exactly what A looks like. OA after t seconds is going to be the position vector of A at t equals to 0, which means where it started from. So that is 1 and 5 right here. Okay. And in it, you add the velocity vector of A, which we now know is, it's talking about A, right? Yeah. So which we now know is 4 comma minus 3. So 4 and minus 3, and then you multiply it by t. And just like that, it says state the position vector of b after t seconds. So the position vector of b after t seconds means the position vector of b at t equals to 0, meaning where it was starting from. So that is q and minus 15. So we don't know the x component. So koi baat nahi, we'll write it as it is. Okay. Plus the velocity vector, which is 3 and minus 1. Alright, so here we have 3 and minus 1, and after t seconds means that we're going to multiply it by t. Now, okay, without looking at the next part, can you guys take a guess as to what the next part is going to be? Sir, I followed you from both my accounts on okay, I appreciate that. Mahant? Can we write AB as OA plus OP? No, that's incorrect. You can write it as AO plus OB. You need to use either head to tail rule. You need to either add the two vectors or subtract the two vectors. Okay, so use the rule of vectors to find out AP. Okay, so you guys have probably seen what the next part is, right? Okay, something to do with the collision. So you guys are close. Find the time until A and B meet. So here we don't have to find out whether they are meeting or not. We don't have to prove whether they're meeting. We don't have to disprove whether they're meeting. Here we just need to find out the time until they meet, which means that they're definitely meeting. And we need to, like I said, find out the time. Okay. So in this case, what are we going to do? We're going to equate their position vectors. So OA after t seconds, we're going to equate that with OB after t seconds. So OA was what? Is going to be 1 plus 4t. So 1 plus 4t, and then 5 minus 3t. Okay, so we're going to equate that with OB after t seconds, which means q plus 3t, q plus 3t, and minus 15 minus t. So minus 15 minus t. Now if you think about it, I can't use the x components to find out the value of t. I can use the I can only use the y components. So that's what I'm going to do. I'm going to use the y components. I'm going to equate them. 5 minus 3t is equals to minus 15 minus t. So 5 plus 15 is equals to minus t plus 3t. So 20 is equals to 2t, which means t equals to what? T is equals to 10. Okay, so t equals to 10 seconds. Then it says find the position vector of the point where A and B meet. Now, in order to find out the position vector, technically you can substitute the value of t in either the position vector of A or B. But here, since we can only work out the actual value from using the position vector of A, so that's what I'm going to do, because B ka hamare paas ye Q ki value nahi hai. So 1 plus 4 into 10, 5 minus 3 into 10. Alright, so let's figure this out. 4 into 10 is 40, 40 plus 1 is 41. Alright, so here you go, 41. Minus 3 into 10 is minus 30, 5 minus 30 is negative 25. So there you go, that's it. That's your answer. Sir, why can't we use x component? Okay, go ahead, try and use the x component. You will most likely find the answer to your question. And when you do find the answer to your question, let me know. Okay, go ahead. For those of you who are saying, why can't we use the x component? Go ahead. Use the x component. You'll find the answer to your question. And then let me know what you found. Okay. Here it is. Use the x component. Equate these two. And find out the value of t. Okay. Then it says find the value of the constant q. Okay, अगर आपको अभी तक नहीं मिला तो फिर आपको इस पार्ट में मिल ही जाएगा कि हम क्यों नहीं यूज़ कर सकते x component. Okay. Alright, so now we know what it looks like. Q plus 3t q plus 3t and minus 15 minus t is going to be equal to what? Is equal to 41 and minus 25. Okay. अब देखो t की वैल्यू तो हमारे पास है ना, सही है. So there's no point in solving this again because we're going to get t equals to 10. Okay. But what we will do is we will take t equals to 10 and we're going to plug it in this equation. So t equals to 10. So q plus 3 into 10 equals to 41. So q plus 30 equals to 41, which means q is equals to 11. ठीक है, मिल गया आपको अपने सवाल का जवाब. आंसर इज कमिंग 0. किसका आंसर 0 आ रहा है? ज़ीरो तो किसी का आंसर नहीं आ रहा बेटा. How did you get 0? Where did I get 0? Sir, will you be completing the whole syllabus? बेटा परसों पेपर है, मतलब क्या लगता हूँ मैं आपको? I understand I'm wearing a Superman shirt, but that doesn't mean that I am one. Yeah, I will solve the baddest and the meanest questions today on Twitch. Yes, synthetic division is allowed. Synthetic division is allowed. Insanely difficult. Alright, let's do insanely difficult questions, shall we? अच्छा ये एक ही question दो दफ़ा आया हुआ है, so I'm just gonna delete this real quick. Okay, so do you guys want to do like the most difficult question, or do you guys want to do a slightly less difficult question first? Please let me know. Do you guys want to straight away do an extremely difficult question, or do you guys want to do a slightly less difficult question first? Slightly less. Straight away extremely difficult. Nah, I don't think I should do that. I don't think you guys can handle the most difficult question just yet. Maybe we do a slightly less difficult question, then you guys can handle the insanely difficult question. चलो ये करते हैं. It's fairly recent as well, and it's also difficult. I mean, not part A, but part B is difficult. Okay, but not like the most difficult, just slightly less difficult question from the most difficult question. Okay, so here we go. So this question here says, in this question, I is a unit vector due east and j is a unit vector due north. A cyclist rides at a speed of 4 meters per second on a bearing of 15 degrees. Write the velocity vector of the cyclist in the form xi plus yj, where x and y are constant. So again, you have a question which is asking you to write down the velocity vector, and you have to do that through the speed and the bearing. Okay, so again, very similar to what we just did. So here's what we're going to do. 4 meters per second, that means we know what the magnitude of the, you can say, hypotenuse is. And 15 degrees means, bearing of 15 degree means that it's going to be something like this. Okay. Now you can make a triangle over here and then break it down into x and y component, or you can make a triangle over here. I would prefer to make a triangle over here. Okay, matlab I would prefer to draw the x over here, you know, coinciding with the horizontal axis, and y parallel to the y axis. Okay, or you could draw it like this, that the y component coinciding with the y axis and the x parallel to the x axis. Okay, you could do it like that as well. So here is 15 degrees. Okay, let's break it down into x and y components. So here's the x component, which I'm drawing in green. Okay, and then and then draw the y component, which is right here, that I'm drawing in blue. Okay, so yeah, there you go. So let's color code this. Here's x, here is y. Okay, and the red line is 4. Okay, So this angle is going to be what? This angle is going to be 75 degrees. Okay, I hope no one's wondering how I got the 75. If you are, then I'm afraid I have bad news for you. So anyway, let's start with x. So x is the adjacent side, and we have the hypotenuse, so that means we're going to use cos. So cos 75 equals to adjacent over hypotenuse. So x equals to what? X is equals to 4 cos 75. Now I would prefer to keep it in terms of sine and cos only. Okay. Then let's talk about y. So y is the opposite side, and we have the hypotenuse, so that means we're going to use sine. So sine 75 equals to what? Equals to opposite, which is y, over hypotenuse, which is 4. So y is equals to 4 sine 75. Okay. Now let's write it the way the question wants us to write it. That is xi plus yj. So if we do that, here's what we end up with. 4 cos 75. You can make a bracket around it. Write I plus 4 sine 75. Again, you can make a bracket around it. Write j. Okay. And then if you want, you can write it as, you can write it in decimals also. Okay. Not 90 plus 15, 90 minus 15. Okay. So that's the first part. Okay, pretty easy. Now let's talk about the next part. Okay. If GP functions range domain, can it come again? I think the quadratics part can come again. Okay. The quadratics part can come again. Alright. Sir, always cos will be x. देखो बेटा इस तरह के उल्टे सीधे रट्टे नहीं लगाओ कि cos हमेशा x होगा और वो हमेशा y होगा. हाँ, एक चीज़ जो मैं आपको बता सकता हूँ वो ये कि the adjacent side, whether it is the horizontal or the vertical, will always have cos in it. The opposite side will always have sine in it. ठीक है. So like I said, इस तरह के उल्टे सीधे रट्टे ना लगाएं आप, थोड़ा दिमाग इस्तेमाल करना है. Sir, do you think subjects like math and Addmath should be illegal? Okay. Alright, now, so here's part B. Part B says a vector of magnitude 6 on a bearing of 300 degrees is added to a vector of magnitude 2 on a bearing of 230 degrees to give a vector V. Find the bearing and magnitude, find the magnitude and bearing of V. Okay. Now, let's figure this out. So first of all, we need to break this question down into two parts. Okay, we need to first find out, we need to break this vector up. Okay, a vector of magnitude 6 and on a bearing of 300 degrees, and then we need to break this vector down, which has a magnitude of 2 and on a bearing of 230 degrees. Okay, so एक काम करते हैं, let's call them A and B. Okay, so here's vector A, which has a magnitude of 6 and bearing 300 degrees. All right, then let's talk about B, which has magnitude 2 and bearing 230 degrees. Can we write it in root? Cos और sin की फॉर्म में इसलिए recommended है क्योंकि, okay, let me reevaluate what I said. Now, okay, so because we're not going to use it in part B, so it's actually not necessary whether it's not necessary whether you write it in cos or sin or whether you write it in decimal. Okay, so if you guys want to write it in decimal, go ahead. I thought maybe we'll have to use it in part B, so I didn't want to deal with a lot of decimal. That's why I preferred to keep it in terms of sin and cos. So this, by the way, becomes 6 minus under root 2. You know, that's also not too bad, writing it like this. 6 minus root 2 and 4 sine 75. Let's see what that is equal to. That becomes under root 6 plus under root 2. Yeah, so that's also not too bad. Okay, or again, you can write it in decimal as well. Okay, you can write it in decimal as well. Go right ahead. So yeah, nothing wrong with that. Now, so let's break down vector A. ठीक है, अब vector A को ज़रा analyze करते हैं. Vector A is a vector which has magnitude 6 and it's on a bearing of 300 degrees. So on a bearing of 300 degrees means that it's going to land in the first, second, third. It's going to land in the third quadrant if you count it clockwise. And actually it's going to land in the third quadrant irrespective of how you count it. Okay? So bearing of 300 degrees means that it's going to land over here. Okay? Now landing over here means what? Means that its x and y component both are going to be negative. Okay? So let's do that. Let's make the x component in green, okay, and the y component in blue. All right. So here we have the x component of A, and here we have the y component of A. Okay. Now what is the hypotenuse? The hypotenuse is 6. Now because the bearing is 300 degrees, अच्छा wait a minute, this is not 300 degrees, this is 230 degrees. ये मैंने गलती से 230 degrees बना दिया. Okay, yeah, you're right, ये मैंने गलती से 230 degrees बना दिया. It's चलो एक काम करते हैं. Let's drag this over here. Okay, इसका मैं separate कर लेता हूँ. Okay, so this is on a bearing of 300 degrees, so that means 300 degrees. I fixed it, boys. I fixed it, boys and girls. I fixed it. Relax. So 300 degrees. This is 0. This is 90. This is 180. This is 270. Yeah, here's 300 degrees. ठीक है, अब सही है. So 300 degrees is going to be in between 270 and 300. Is it? No, it's not going to be in between. It's actually going to be closer to. Okay, it doesn't really matter, but yeah, it's going to be something like this. Okay, quadrant सही है. अच्छा, फिर let's see what we're going to do. Let's calculate this angle over here. This is 300 degrees. Okay, and if this is 270 degrees, that means this is going to be 30 degrees. Okay, now let's break this down into x and y. So here is the x component, okay, and here is the y component. Okay, so let's color code this as well. Here's the x component and here is the y component. Okay, acha, now keep something in mind, and that is because this is in the second quadrant, its x is going to be negative and y is going to be positive. All right, so if you want, as a safety precaution, you can write this over here, that whatever the x component you find out, it has to be multiplied by minus y component. However, you'll take it as it is. Okay. Okay, now, so let's break this down into x and y. Now what is the hypotenuse? The hypotenuse is 6. So that's 6 right here. Okay, so let's find out the x component. X component ke liye, like I said, we will use adjacent, because x component is adjacent, so we will use cos. So cos 30 equals to adjacent over hypotenuse. Now let's cross multiply. So this also I would prefer to keep it in third form. Okay, so cos 30, close the bracket, into 6. So we're looking at 3 under root 3. Now like I said, remember that this is supposed to be minus because it's going towards the left. Okay, and then just like that, let's find the y component. So since y component is the opposite side, we'll have to use sine. So sine 30 is equals to opposite, which is y, over hypotenuse, which is 6. So y will turn out to be what? Sine 30 is half. Half into 6 is 3. Okay, so that means we have broken down vector A, and this is what vector A looks like. A looks like minus 3 under root 3 upon 3. Okay, so this is what vector A looks like. अब ये 5 mark का सवाल है, so that means you have to be you have to show all the working and you have to do it step by step. Okay, now let's break down B. Let's see what do we have over here. So the x component here is also the adjacent. Now first of all, let's find out this angle. Now because this is 230 degrees, 230 degrees and this is 270. So what is this angle going to be? This angle is going to be 270 minus 230, so that's equal to 40 degrees. Okay. Now, x component is the adjacent component, so here's what we're going to do. We're going to use cos. So cos 40 equals to adjacent over hypotenuse. So what's x equal to? X is equals to 2 cos 40. And here also, as a safety precaution, you can write this down that this is going to be minus x and minus y. Okay? Because it's in the third quadrant, x and y both are going to be negative. Now let's talk about the y component. The y component is going to be sine because it's the opposite. So sine 40 is equals to opposite, which is y, over hypotenuse, which is 2. So y is equals to 2 sine 40. Okay. So that means this is what it looks like. This is what vector b looks like. Now vector b is going to be minus 2 cos 40 and minus 2 sine 40. Okay, there you go. Let me enlarge this a little. Okay, now, so then comes the final step. The final step, and that is we need to find out what? We need to find out the magnitude and the bearing of v. Okay, so v, as we know, is formed by taking the sum of these two vectors. So v is going to be minus 3 under root 3, 3 plus minus 2 cos 40 and plus minus 2 sine 40. Okay. So v equals to what? V equals to the following. V is equals to, up here we have no option but to write our final answer in decimal form. Okay. So it's going to be minus 3 under root 3 plus, in fact, minus 2 cos 40. Make sure your calculator is in degree mode. So you get minus 6.73, the x component, and the y component is going to be 3 minus 2 sine 40. So that's equal to 1.71. 1.714. Since it's not the final answer, since we're going to be using this answer to calculate the magnitude, let's take more than 3 significant figures. Okay. Now the magnitude of this vector is going to be square root of minus 6.73 squared plus 1.714 squared. Okay. So I have the exact value in my calculator. I'm just going to square that, plus 6.73 square, and then take the square root of it. So the magnitude of v turns out to be 6.94. Okay. Now this is the magnitude. The bearing is still left. A bearing निकालने के लिए you can make a triangle. Now because this is going, the x component is left and the y component is positive, that means the triangle that we're going to make is going to be such that it's going towards the left and up. Okay. So this is going to be 6.73. This is going to be 1.714. Here is theta, which can be found by using tan. So tan theta is equals to opposite, which is 1.714 upon adjacent, which is 6.73. So let's take the tan inverse of 1.714 divided by 6.73. So we're looking at theta to be equal to 14.28 degrees. Okay. Bear in mind that we were supposed to give what? We were supposed to give the direction. So how will we calculate? We're supposed to give the bearing actually. So bearing will be calculated by taking 270 plus the answer. So 270 plus 14.28. Let's see what do we get. So plus 270. So we're looking at 284.3 degrees. Let's see if it says correct to the nearest or anything. Nope, it doesn't. So 284.3 is the bearing. So there you go, fellas. That's your answer. So, maza aaya? So what if we leave it in exact form? Go ahead, leave it in exact form. Nothing wrong with that. Sir, what? Please write the essential equation for this topic. What do you mean essential equation for this topic? What does that mean? Sir, can we use the parallelogram method to add the vectors? Yeah, okay. So I'm guessing you're a physics student. go ahead, you can use the parallelogram vectors as well, but I wouldn't suggest, I wouldn't prefer that. Okay, कर सकते हैं आप use, but I wouldn't prefer that. ठीक है. This is not the hardest question. What I'm about to do next is going to be the hardest question. Write the equations. What equation are you talking about, bhai? Summary of the question. Okay, yeah, I can do that. Okay, so here's what I've done. We took the two vectors one by one. Okay, this was a vector with magnitude 6 and bearing. We broke it down into x and y components. We took the other vector with magnitude and bearing, again broke it down into x and y components. All right, then we added the two vectors. What we got as a result is vector v. Now this is the vector of which you need to find out the magnitude and the bearing and the direction basically, and you need to express the direction as bearing. So find out the magnitude by taking the square root of the square of the x component and the square of the y component. Okay, and then using the same xy components find out the angle theta and then write it in bearing form. No, it doesn't work like that. You can't just add the magnitudes of the two vectors and the bearings. It doesn't work like that. Okay, because you need to first find out what the new vector is, and you need to find out the magnitude and the bearing of the resultant vector. ठीक है. Sir, direction की line पे magnitude is 6, and in the previous question you wrote speed value where you have written 6 right now. That's because, okay, देखो. So basically the magnitude or the speed, they're both represented by the hypotenuse line. Okay, so irrespective of whether it is the magnitude or irrespective of whether it's the speed. See, the thing is, in this question, the magnitude doesn't really mean anything. It's not representing a quantity. Okay, but in the case of velocity vector, the magnitude represents the speed. So in that case, speed is actually equal to the magnitude. Okay, so that's why I did what I did. Yes, because देखो, magnitude of the velocity vector is equal to speed. So in that case, the magnitude is equal to the speed. दोनों represent, दोनों आएंगे एक ही जगह पे, दोनों hypotenuse होंगे. ठीक है, लेकिन एक केस में magnitude is just magnitude, it's not really representing anything. In the other case, the magnitude is representing speed. Nothing compares to velocity or speed to log x. Okay, let's do an insanely difficult question. What do you guys say? We do an insanely difficult question? I just watched your last two. नहीं Ibrahim, then I wouldn't recommend that you watch this one. Okay, अगर वो देख के समझ आ गया, so that's good enough. Okay, इस क्वेश्चन में सही मज़ा आने वाला है आप लोगों को. वैसे तो let me tell you guys something. This is a very old question. Okay, you don't have questions like these anymore. But having said that, I mean, I'm not sure. You can. इस साल क्या पता आ जाए, who knows? So I'm not saying कि ये question irrelevant है completely, but हाँ, it's a one-off question. Okay. So anyway, let's solve this. Okay. Let's solve this. Let's see what's what. This was a piece of cake. All right, Sana. That's great if you found this to be a piece of cake. So इसमें वैसे काफ़ी सारी चीज़ें useless हैं, as in you don't need to know exactly. I mean, if you think about it, the names of the towns and the name of the people over here, they kind of stretch the question unnecessarily. But yeah, इसमें हम काफ़ी सारी चीज़ों को हम scale down कर सकते हैं. Like for example, हम बस ये देख सकते हैं कि position vector क्या है two towns का, ठीक है, and we can break down, we can think of Manjeet as like, you know, a particle B moving with a position vector so and so and velocity vector so and so, ठीक है. So you can break it down like that. Anyway, so let's solve this. Let's see what's what. Okay. And also let me tell you, this is from October, November 2016. So it's nearly what? 6 years old? Yeah, 6, 7 years old. Okay. Anyway, so let's read the question, see what's what. It says the town of, okay, so अब मैं इसको short करके पढ़ूंगा. I'm going to call this C and I'm going to call this E and I'm going to call Manjeet M and I'm going to call Raj as R. ठीक है. So the town of C is 5 kilometers east and P kilometers north of E, so that the position vector of C from E is 5,000 and 1,000 P meters. Okay, so first question. How is this 5 and P and this all of a sudden 5,000 and 1,000? How did this happen? How did this happen that all of a sudden it turned into 5,000 and 1,000? Yep, because it's in meters. Okay, good job. Okay, so you guys have passed the first test. Now the real test. Manjeet sets out from M sets out from E at the same time as R sets out from C. M sets out from E on a bearing of 20 degrees at a speed of 2.5 meters per second. So let's highlight that, bearing of 20 degrees at a speed of 2.5 meters per second, so that her position vector relative to E after t seconds is given by so and so. Okay. Raj sets out from C on a bearing of 310 degrees at 2 meters per second. Okay, so we need to find out the position vector of R relative to E after t seconds. Okay, so where is R setting off from? R is setting off from C. Okay, so R sets out from C and we need to write down the position vector of R relative to E. Okay, so first of all, think of it this way. Think of E as O as your origin, okay, and then think of C as a separate point, and you know that the position vector of C from O is equal to what? Is equal to 5,000 and 1,000 P. Okay, so think of it this way. Dekho, even though it's a 2-mark question, but going the extra mile won't hurt. So think of E as the starting point, okay, and then think of it this way, that you have a town C which is 5 kilometers due east, which means it's going to be somewhere on the right, and P kilometers due north, so that means it's somewhere over here. So here is E and here is C. So that means whoever is moving from C has already moved 5,000 and 1,000 P. Okay, it's already 5,000 and 1,000 P displaced. Okay, now whatever happens will happen from this point onwards. Okay, and Raj, who is moving at a velocity of 2 meters per second on a bearing of 310 degrees, that means this is what the scenario is for Raj at least. He is moving like this. So bearing of 300 degrees, right? No, 310. Okay, so pay attention. Here is 0, 90, 180, 270 and 300 degrees. Okay, now this is 2, okay, and if it's 300 degrees, that means this is going to be what? This is going to be 310 actually. This is 310. Okay, so this is 310. So that means the small angle that you're looking at inside is actually going to be 40 degrees. Okay, let me enlarge this a little so you guys can see what's going on. Okay, now let's break this down into x and y. Okay, so the x component I'm going to draw in green, and the y component I'm going to draw in blue. Okay, so here is the x component and here is the y component. Okay, I hope you guys are following. No, this question is not relative velocity. Because relative velocity is something else. That is when the particle is traveling either in water or in air. Okay, this has none of that. This is not relative velocity. Okay. Yeah. Now, so let's find out the x component. Like I said, so the x component is going to be 2 sine 2 cos 40. Chalo, let me not skip a step. Let me do it step by step. So we have the hypotenuse and we need to find out the adjacent side. So that means sine 40 equals to x upon 2. So x is equals to 2 sine 40. Okay, so there you go. No, wait a minute. Cos, sorry. That's going to be cos. Cos 40 equals to x upon 2. So x is equals to 2 cos 40. Okay, now let's talk about y. So y is the opposite side. So for that, we're going to use sine. So sine 40 is equals to opposite over hypotenuse. So y is equals to 2 sine 40. What are we finding? We're finding the position vector of Raj relative to E after t seconds. It's like we're finding out the position vector of a particle, okay, after t seconds. So for that, we need to know the starting point, and in it, we need to add the velocity vector and multiply it by t. Okay, so that's what we're going to do. Now, do keep one thing in mind, and that is that the end vector will have x component as minus and the y component will be plus. Why? Because it's moving towards the left and up. So left and above means x is minus and y is positive. So this is what we're looking at. We're looking at OC, or you can say, in fact, no need to write OC, वरना फिर खामखा examiner परेशान हो जाएगा. So here's what we're going to do. 5000 and 1000 p plus the x component, like I said, is going to be negative. So minus 2 cos 40. And the y component will be positive. So that's going to be 2 sine 40. And this we multiply by what? This we multiply by t. Now, like I said, even though it's a 2-mark question, but going the extra mile will just help you in a way that you will be quite sure of your answer. Okay? And will help you understanding the question as well. Okay, so there you go. That's your answer. Then comes part 2. Part 2 says Manjeet and Raj meet after t seconds. Okay. Manjeet and Raj meet after t seconds. Okay. So the thing is that as far as so as far as Manjeet is concerned, we already have her position vector after t seconds, and that is this. That's 2.5t cos 70 and 2.5t cos 20. Okay, and if they're meeting, what does that mean? That means that we're going to equate their position vectors. Okay, so if they're meeting, that means we're going to equate position vectors. Okay, so let's take the position vector of Raj. Alright, so here's the position vector of Raj, and let's rewrite the position vector of Manjeet, which is 2.5t cos 70 and 2.5t cos 20. Okay, so this is M. Alright, and for R, it's going to be 2.5t cos 70 and 2.5t cos 20. Okay, now I have a question for you guys. What component should I use to find out the value of t? Should I use the x component or should I use the y component? Question for you guys. So 5000 minus 2t cos 40. So I multiplied this by t and I've written the t next to 2. Okay, and here we have 1000p plus 2t sine 40. Okay, so this we're going to equate with 2.5t cos 70 and 2.5t cos 20. Let me make sure that I've copied everything correctly. 2.5t cos 70, 2.5t cos 20. Okay, brilliant. Alright, why x? Why not y? I'm sure कोई तो सोच रहा होगा कि y क्यों नहीं यूज़ करेंगे. Mods are too strict. Really? क्या delete किया mods ने? Let me check. Sir, why are we taking Cambly? You have to find. Okay, there was no need to delete that. I kind of agree. Yeah, okay, ये आपने बिल्कुल सही delete किया. अच्छा, फिर. Yeah, again, there was no need to delete that. Alright, just dial down the strictness a little. Okay. Yeah, so we're going to use the x component. That's because y has p. Okay, you're right. So we have 5000 minus 2t cos 40, which is equal to 2.5t cos 70. ठीक है, अभी ये सही आपके algebra का इम्तिहान है. ठीक है. So we'll first take all the t's on one side. So 5000 equals to 2.5t cos 70 plus 2t cos 40. So from the numerator we'll take t common. Okay, so we'll take t common from the numerator. So t and 2.5 cos 70 plus 2 cos 40. Alright, and then let's make t the subject. So t is equals to 5000 over 2.5 cos 70 plus 2 cos 40. So anyone who can work this out and tell me what the answer is? Yes, and I'll do it myself as well, but I'd like someone else also to figure it out and see what the answer is in case I make a calculation error or something. 5000 over 2.5 cos 70. Don't forget to close the bracket after you write 70 plus 2 cos 40. Again, don't forget to close the bracket after you write 40. So we're looking at 2094.55, which if we round off correct to 3 significant figures, does it say that by the way? No, it doesn't. But if let's say we do it anyway, so it's going to be it can't be 2094, so it has to be 2100. Now I know 2100 is 2 significant figures, but if you round it off correct to let's say 3 significant figures and it ends up being rounded off as 3 significant figures, so that's okay, that's not your problem. Okay, in fact, wait a minute, you can actually round it off as 2090 as well. Yeah, so 2090 seconds as well. 2090. Yeah, in fact, you will round it off to 2090. Okay? But when you're calculating p, do keep one thing in mind, that when you're calculating p, you will not take the rounded off value. You in fact use the answer key. Okay? So when you're calculating p, I would suggest that you use the answer key. So first of all, let's form an equation for p. So 1000p plus 2t sine 40 is equals to 2.5t cos 20. Okay, so let's make p the subject. So 1000p is equals to 2.5t cos 20 minus 2t sine 40, and then p is going to be equal to, now I'm going to use the answer key like I said. So 2.5 answer into cos 20 minus 2 into answer into sine 40 divided by 1000. Okay, so let's see what's what. 2.5 answer into cos 20, close the bracket, minus 2 answer in the bracket, and then sine 40, close the bracket, over 1000. So we're looking at 2.227. So p is equals to 2.227, which means p is equals to 2.23. There you go. That is your answers. I mean, these are your answers. Now let me know what your thoughts are on this question. Yeah. Yep, I'm aware of that. I am aware of that. Sir, in part 1, why did we take Cambly position vector? Please don't. Okay. In part 1, dekho, we need to find out the position vector of Raj relative to Edwin town, and Raj is moving from a town, Cambly, which is at a position vector of 5000 and 1000p relative to E. So think of it this way, that you have a point C and E is the origin. So C is 5000 and 1000p away from the origin in vector terms, okay, and from the point C you have someone which is who is moving on a bearing of 310 at 2 meters per second. So that means we need to find out, we need to form a vector, we need to find out the position vector which gives the position relative to E. So E is our starting point. Okay, that's why I did what I did. I hope that answers your question. Okay, so like I said, moderators, please dial down the strictness level. Okay, so what time is it? It's 4:37. Yeah, article. सही बात है. पूरा article नहीं thesis था ये. Anyway, so you guys want to solve one more question? चलिए काम करें, ये question solve करके दें मुझे. हाँ, ये वाला question मुझे solve करके दें. Part 2 में you had to take the position vector of both the particles of both the people, okay, Raj and Manjeet, and equate them, okay. Theoretically, that's what you had to do, but the question became difficult because you had to first make T the subject, so this really boiled down to your algebra skills, algebraic manipulation skills, okay. If you think about it, there is nothing new in part 2 because they're meeting, we're equating the position vectors. Now once you equate the position vectors, you first make T the subject before you evaluate it, okay. Yeah, so here's the question. Go ahead and solve this. I will be solving yearly past papers, Marine. Velocity vectors is rarely tested. Yes, it is rarely tested. I agree with that. But if it is tested, then that means it's going to be quite detailed. Okay, अगर test हो गया तो काफ़ी detailed question होगा. So how to solve factorial question? It's too hard. No, it's not. It's not. Just remember the simple trick that you use to solve factorial related questions. Should I drop Addmaths in class 10? Well, depends on how you're performing in class 9. Anyway, do we have the answer to this? Yes, no? So how do you think the response to this year's P1 was worse than last year's P2? Yeah, I think it was more or less on the same level. More or less on the same level. I just hope paper 2 doesn't top that. Sir, can you do a video on NCRs? The last question at the bottom just said. Okay, just watch my video on either permutation and combination or watch my video on binomial. You will learn how to expand NCR without using a calculator. Okay, it's very simple. 3i minus 6j. Okay, let's see if that's the answer. Yep, 3i minus 6j is the correct answer. Good job. So here's what we're going to do. We're going to take 3 under root 5, multiply it by, let's first find out the magnitude, which is going to be square root of 1 square plus minus 2 square, which means it's going to be square root of 5. So multiplied by I minus 2j over under root 5. So root 5 and root 5 gets cancelled. And now we have 3i minus 6j. ठीक है, good job. Okay, now do part 2. Part B. Is question 10 solved? Yeah, I think it is. Yep, question 10 is solved. I think you missed it. No issues, you can always go back and check. Could you do the specimen paper? But the specimen paper is for 2025 and onwards. कौन है Aisha? Aisha, specimen paper is for 2025 and onwards, so it's not entirely relevant for us. Specimen paper always is released every time there is a change in syllabus. There is a major change. Okay, so which is why the last specimen paper that you will see will be from 20 in I think 2020. Yeah, 2020 mein, because there was a major change in syllabus, that's why we had the specimen paper. Under root 3 plus 1j. Yeah, I think that's correct. So you guys are definitely onto something. The velocity vector w makes an angle of 30 degrees with the positive x-axis such that the magnitude, again, so this is the exact same piece of information, it's just that it's given to us differently. It's not given to us the usual way where you have the speed and you have the speed and the bearing. It's just that you straight away have the angle that this hypotenuse is making with the x-axis. It's 30 degrees. So again, break it down into x and y. So अब एक shortcut याद कर लो तो थोड़ी आसानी हो जाएगी कि x वाला जो component होता है वो I'm talking about the adjacent components. Okay, the adjacent component always has cos. The opposite component always has sine. Now, that does not mean that x will always have cos and y will always have sine. Whatever the adjacent component is, whether it's representing x or y, will always have cos. Okay, whatever the opposite component is, whatever it is, whether it's x or y, will have sine in it. So x is going to be equal to what? X is going to be equal to 2 cos 30. Okay, and y is going to be equal to what? Y is going to be equal to 2 sine 30. Okay, so this becomes, let's see what this is, 2 cos 30 is equals to under root 3. So this is under root 3i plus sine 30 is half, so half into 2 is going to be 1. So there you go, under root 3i plus 1j, and because it's in the first quadrant, so they're both going to be positive. So there you go, root 3i plus 1j. Okay, did I miss anything? Yes, Mariam, I have uploaded the notes. You'll find the notes in the description. Okay, you'll find the notes of this topic in the description. Anyway, so I think let's call it a day over here. What do you guys say? And I'll see you guys in 15-20 minutes where we will be solving past papers. Okay. Sir, could you please explain? Okay, if this is a velocity vector question, then yes, I can solve it. ठहरो, क्या बोला आपने? May, October, November 2018, paper 2, variant 2. October, November 2018, paper 2, variant 2. Okay, I'm solving one more question, alright? I think this is a velocity vector question. Can you tell me the question number? Question 12. Okay, this is not part of the syllabus, alright? This is not part of the syllabus. See, notice how here you have still air. Every time you see something to do with still air or maybe still water, just ignore that completely, okay? It's not part of the syllabus, so don't worry about it, okay? So, see you guys at 5 p.m. on Twitch, okay? So, yeah, that's it. Take care, everyone. Allah Hafiz. I've shared the link I've pinned the link, and I made a post of it as well, so you guys can get the link from there. It's basically Mathlete by Saad. Alright, just look it up, Mathlete by Saad. मिल जाएगा आपको.